Welcome to section 8.4. In this section we will be multiplying and dividing square roots. So let's get started. All right, so when you are multiplying, we will need a rule. So this is the product rule. It's the same product rule that we used back in section 2, so that's the good news. But this time, instead of taking them apart, we're putting them back together. So if you have the square root of a times the square root of b, you can actually keep the square root. Notice they both have the same radical. They both have square roots. And then you can just multiply your radicands. And then once you've done that, then it's a little bit easier to see how you can break it down. I would definitely not encourage you to break down each radical separately and then multiply them together. It gets a little hectic if you do that. So we're going to multiply them together first and then look at this result and then break it down. All right, so let me show you some examples. All right, the square root of 7 times the square root of 5. It's really important that you read the directions on these. It tells you to multiply, then simplify. So definitely do the multiplication first. So first thing we're going to do is we're going to multiply those two radicands. And we know that 7 times 5 is 35. All right, then it says, then simplify if possible. So can we break down 35? Unfortunately, no, there is no perfect square. That is a factor of 35. So that would be our final answer. All right, let's look at B. Same problem, root 3 times root 15. Okay, so we are going to multiply those radicands first. So 3 times 15 is 45. Okay, so then simplify. Can we simplify 45? Yes, 45 we can break down into 9 times 5, which is 3 root 5. So there would be our final answer, 3 times the square root of 5. So notice, very simple. Multiply first. Whatever your result is, simplify that. All right, this also works if you have variables in your radicands as well. So you're going to do the same thing. You're going to multiply those two radicands. All right, so 3 times 6 is 18, and x squared times x to the 5th is x to the 7th. Okay, so we've done the multiplication. Can we simplify this? All right, 18. 18 we can break down as 9 times 2, and x to the 7th we can break down as x to the 6th times x. So these two are both our perfect square, so they're going to go in front. So that's 3, and then this would be x to the 3rd, and then our leftover radicand is root 2x. So there's our final answer, 3x cubed times the square root of 2x. So notice, same procedure. Multiply the two radicands and then simplify whatever that radicand is. All right, multiplication does show up in some different ways. It's not just monomials times monomials, like one thing times one thing. We are going to have multiple terms. So in this case, anytime you see the parentheses, we're going to get rid of these just like we did back in chapter 5. So in this sense, we're going to distribute first. So root 3 times root 3 is root 9, minus root 3 times root 2 is root 6. So we've done the multiplication. Okay, we've gotten rid of the parentheses. Can we simplify? Square root of 9 is 3. And 6 we can't simplify, right? There's no perfect square factor. So there's my final answer, 3 minus root 6. B, this time we have 2 terms times 2 terms. Very important though that you realize this is actually a special pattern that we talked about back in chapter 5 and in chapter 6. Okay, this is the difference of squares pattern. Notice I have the same 2 terms, one's adding, one's subtracting. So rather than doing FOIL, you're more than welcome to do FOIL. I just think you're going to be wasting a lot of time. I'm going to go right to my pattern. That is a difference of squares pattern. So the root 3 is in the first position and the 8 is in the back position. So remember, a square and a square root will kind of cancel each other out. We're left with 3 minus 8 squared is 64. So that is negative 61. So don't forget all those special patterns we talked about. Those are going to come back on and off all through your mathematical career. All right, another thing that you could see is what happens if you have some weird thing like this and the whole thing is squared. Okay, this is one big term. It's one big thing we have multiplied together. So what we can do is multiply that coefficient out in front, and then, so we're going to square that, and then we can square the radical as well. So square everything. So the 6 gets the square, which makes it 36 x squared times, right, over here the square and the square root will undo each other. So this is just 3y. We're just left with the radicand. So let's see, 36 times 6 is 108. and then x squared y. That we can't put those two together because they have different bases. So there would be my final answer, 108 x squared y. All right, so if you feel like you're ready, set 10 minutes on your timer and see if you can do these 4 problems. I will see you when you're done. If you don't feel comfortable, just keep letting this play and we will walk through these 4 together. All right, here we go. So again, we need to multiply. So the first I'm going to multiply these coefficients, right? -4 times -1. So you can write it all out if you want to. I'm going to write it out. -4 times -1. And then I'm going to multiply my radicals, my radicands there. So that gives me +4 times the square root. 15 times 3 is 45. And we all know how to break up 45. We've been doing that for a while now. That's 9 times 3 and 9 times 5. So let's see, I'm going to lose some space here. So 4 times 3 times the square root of 5 gives me 12 root 5. So there's my final answer, 12 root 5. All right, let's go to the next one on the right. All right, so first of all, 20 times 20. Okay, that is 400. And then x squared times x is x cubed. Now, 400 is a perfect square. We just saw that 20 times 20. So I know 400 is a perfect square. And then x cubed, I'm going to have to break down into x squared times x. So this gives me 20x root x. Next up, here we go, lower left. 4 times 1 is 4. And then we're going to multiply these. 18 times 3 is, that's 54. I'm going to double check on my calculator just because it's been a long day. And sometimes my brain doesn't work. All right, yes, I was right, 54. So 54, and then a squared times a squared is a to the 4th. All right, 54. Okay, what's the largest perfect square that goes into 54? That'd be 9. So that's going to be 9 times 6 is 54. a to the 4th is a perfect square. So that's a perfect square, and that's a perfect square. So we're going to keep the 4. Square root of 9 is 3. Square root of a to the 4th is a squared, root 6. So that gives me a final answer of 12a squared times the square root of 6. All right, and last but not least, here in the lower right, so we have 3 times a radical. Notice, this one doesn't have a radical, so we're just this is gonna be 3 times the square root of 14x. There's really nothing we can do there. Minus, all right, these two, I can multiply these radicands together. 14 times 2 is 28, and x times x is x squared. So I can definitely break that one down. 14x, there's nothing I can do. 14 is just 2 times 7, so that one just stays. Minus, all right, 28, that is 4 times 7, and x squared is a perfect square. So these two will simplify. So again, that first term is going to stay right where it is, minus square root of 4 is 2, square root of x squared is x, root 7. All right, so there are my 4 answers. All right, so how do you feel about multiplication? Okay, and it could be one term, it could be 2 terms, it could be any kind of possibility could happen with multiplication. Oh, and there's the 4 answers. So in case you need those without my chicken scratch, there's the 4 answers typed out nicely. All right, when you are dividing, so that's the next thing we're going to do. So we've done the multiplication, now we have left is dividing. Dividing, same thing, same quotient rule we used back in section 2, but this time we're going to put it back together again. So if you have a radical in a numerator and radical denominator, okay, square root in the numerator, square root in the denominator, you can divide those radicands. So keep the square root, divide the radicands. Just remember that you can't have b as 0, right? Can't have a 0 in the denominator. All right, so again, following the directions is very important. Divide first, then simplify. Okay, so let's do the division first. So what is 14 divided by 7? That is the square root of 2. And can we simplify 2? No, 2 is a prime, so we can't simplify it, so that would be our final answer. All right, B, same thing, divide your radicands. So 100 divided by 5, so that gives me the square root of 20. And then 20, can we simplify that? Yes, we can break it up. 20 is 4 times 5, so that gives me 2 root 5. So there's my final answer. So again, divide them first, then simplify them. Same thing goes if there's variables as well. So let's do an example where we've got variables. All right, if we have variables, again, square root stays, you're going to divide your numerator and your denominator. Okay, this is very reminiscent of the quotient rule that we did back in chapter 5. Remember, when you are dividing like bases, you subtract their exponents. So that was going to be a to the 4th, right? 7 minus 3 is 4. Here, b's, 6 minus 2 is 4. So we've done the division using our exponent rules from chapter 5. Both of these are perfect squares, right? A to the 4th, square root of that is a squared. Square root of b to the 4th is b squared. So those were both perfect squares. So that turned out very nicely. And there is your final answer, a squared, b squared. All right, so if you feel like you are ready with multiplication and division, I would challenge you to take your timer, set it for 10 minutes, and see if you can do these 4 problems on your own without looking back at your notes, without, looking up anything in the book. All right, so press pause and give it a try. All right, welcome back. So here we go. Let's work through these problems. All right, so if I multiply my radicands, I get 3x to the 6th, y to the 4th. Right, square root of 3, nothing I can do with that. X to the 6th is a perfect square, as is y to the 4th. So both of these are perfect squares. So they're going to go in front, x cubed, y squared, and then your root 3 is going to go on the end. So there is your first problem. Let's do the multiplication underneath that as well. Root 8 times 6, again, 6 times the square root of 8, plus root 8 times root 2 is square root of 16. All right, so we've done the multiplication. We got rid of the parentheses. Now let's simplify. So 8 is 4 times 2. So this is 6 times 2 times the square root of 2, so 12 root 2, plus, actually just bring that down, square root of 16. 16 is a perfect square, so that is 4. So there's my final answer, 12 root 2 plus 4. All right, division. All right, so first thing I'm going to do is divide those radicands. So 50 divided by 5. Actually, if you want to, maybe just rewrite them. For some reason, I always feel more comfortable when they're written like that. I don't know why. But 50 divided by 5 is 10. A cubed divided by a is a squared. All right, 10, we can't break down 10. That's 2 times 5, so that stays. But a squared is a perfect square. What's the square root of a squared? That is a, so that's a root 10. So there's my final answer for that one. All right, and the last one, 300 divided by 25. Might need my calculator on this one. I do believe that is 12. Or if I have 12 quarters in my pockets, I got $3. Oh, that sounds about right. All right, 12 I can break down. That is root 4 times root 3. So my final answer is 2 root 3. All right, so there, here, let me show you all 4 answers again. All nice and typed up. So here are your 4 answers. All right, so that ends chapter 8. Again, we are only doing square roots, so you can kind of disregard anything else you see in your textbook or anything you see in the My Math Lab videos about any other roots. We are only focusing on square roots. So I would defer you to the Blackboard videos that I have posted in your Blackboard that go through just working with square roots. All right, thank you so much. Good luck on your test.